next topic is if we have atomic radius or atomic radii, we also have the radius or radii for ions. Okay, so this time we have a different discussion since the radius differs if we have a positive ion or cation and we have negative ion or anion. So this time, we still have the definitions for cations. So for example, the cations, lithium, okay, so lithium plus. So after removing one electron for the lithium. So as we can see, the neutral atom lithium has 157 picometers as its radius. Okay, and the lithium plus has 90 picometers as its radius. So why is that? Okay, let's take a look at the number of protons and electrons in the lithium and lithium ion. So for the lithium, we have 3 protons and 3 electrons. Therefore, the charges will cancel and then the charge will be equal to 0. So this is a neutral atom. While if we have the ion, so meaning we have a charge, so we still have 3 protons at the nucleus, but this time we remove 1 electron, so therefore we only have 2 electrons. So the net charge for this is positive 1. Okay, so by removing an electron, this means that these 2 electrons or the 2 remaining electrons will be attracted strongly in the nucleus having positive 3 charge. Therefore, these 2 electrons will be attracted strongly, and therefore it will go nearer in position in the with respect to the nucleus. Okay, so all of the cations, since all cations have been removed with 1, 2, or 3 electrons, so they will have a larger proton nuclear charge because of the protons than the negative charge by the electrons. So they will attain a smaller radius. For anions, on the other hand, anions receive an electron. Therefore, for example, in this fluorine, so after getting additional 1 electron to become fluoride ion, so this we have a net charge of negative 1, so we have F minus 1. So this charge by the protons inside the nucleus, we have positive 9, and we now have more electrons, so we have negative 10, in which case the added electron will correspond to an additional electron cloud for the electrons found in revolving the nucleus of fluorine. So this will mean that the valence shell of the fluoride ion will be much larger than the valence shell which are occupied by the valence electrons of the fluorine atom. So as we can see, 72 picometers is the radius of fluorine atom, while on the fluoride ion, we have 119 picometers. So in general, all the anions will have larger electron cloud, therefore it will have larger ionic radius than the neutral atom. So this is different from the generalization on the cations. So if we take a look at this one, so groups 1A, 2A, 3A, 6A, and 7A. So groups 1, 2, and 3A, so they will form all positively charged ions or cations since they will be removed with 1, 2, or 3 electrons. So as we remove more electrons, the radius or the ionic radius will become smaller. So for example, we have here the lithium ion, 90. So for the beryllium, we will remove 2 electrons to become Be2+. So this has smaller ionic radius. Okay, and then this one, boron, which is 41. So much more smaller than beryllium 2+. So for groups 1A, 2A, and 3A, so we have a smaller or a decreasing ionic radius. For this one, we have the anions part, group 6A and group 7A. So we have here oxygen. So oxygen will, from 6A, it will gain 2 electrons. So this will be 126 picometers. And then for group 7A, we have fluorine. So it will just gain 1 electron. So it is 119 picometers. So as we can see, the group 6A, or in the oxygen atom, we added more electrons. Therefore, it is larger, or it has larger electron cloud than the electron cloud found in the fluoride ion. Okay. So at this half of the figure, we see that from left to right also, or across a period, in the groups 6A and 7A, as we add less electron, so this one we have 2 electrons, this we have 1 electron, the electron cloud becomes smaller. Therefore, we have a smaller ionic radius. So again, we have different radius, or we have different radii for atoms going cation and atoms going anion. Okay. So we have this 90 to 59 to 41, and this time, since we added electrons, so this is 126. But after this, it will be 119. So it will also go smaller. So it is also found here, okay, in this figure, that as we go along from top to bottom, it is still the same with the atomic radius, wherein we have a larger main energy shell or main energy level that is occupied by the valence electrons. So as we go from top to bottom, it's still the radius will be bigger. That's it for 5.10 ionic radius.